My name is Billy. I am going to be presenting minimum viable game chain Validium. Is that full screen? No. All right, first quickly about myself. So I'm the founder of a recently formed game company called Trifle Labs, spun out from 1KX as recently entrepreneur in resident there. Prior to that, I was running the Interchain Foundation, which is the foundation for the Cosmos network. And in parallel to that, I've been running an NFT gallery called Folia. And I got into the space with an on-chain game from 2017 to 2019 called Clover's Network, if anybody wants to go through the NFT history lessons of early proto, pre-NFT and AMMs. But today, I'm here to talk about on-chain games, and I wanted to begin with a little bit of just remembering why on-chain. The first sort of phrase that I like to think of, there's four of them, is persistence. I'm sure many of you all are familiar with this, but just the general concept that the game itself will continue past any one single party, developer, company. That idea of persistence, I'd say actually it's really a myth of persistence, pervades all blockchains. But I like to think that even if it's a myth, it's a credible threat of a myth. It's we have enough assurances that we can at least build in a way that we assume things will persist, which really changes the mentality of how you build things. This meme, of course, is the joke about the origin of Ethereum, which the story goes came from a update to from Blizzard Software that borked one of Vitalik's game assets, and he was so upset with this idea that there's no persistence in this thing that he's imbued so much value in that he wanted to create a world computer that would persist forever. The other one is community ownership. So here I have the freedom of speech meme, in which the people that care about the system the most are the ones who should be entrusted into running it. This idea that if a system is built in this way, it can be sort of turned inside out, so that the operation of it takes place from the inside of the actual game rather than from a top-down sort of perspective. Of course, we all know that premature community ownership can be really dangerous. There's the tragedy of the commons and the idea that sometimes the people who are most suitable to make decisions on the system are not yet the majority of the users of that system. And so finding the right balance there is, of course, always hard. I would suggest that when building on-chain, you maybe don't want to begin as fully community-owned as possible. The next one is composability. We're, of course, all familiar with money as Lego bricks, the idea that if persistence is part of your system, you can reliably build on top of it. You can build unforeseen extensions. You can modify it in a way that you're able to depend on the persistent underlying system to continue being there and build on top of it. Composability also has a double-edged sword, of course. If you're familiar with building games, you know that often there are, similar to traditional companies, there's good users and there's bad users. I'd say that often bad users inside of games take the form as bots. They can very quickly sort of deter or decrease the player experience for your good users, your paying users, your organic users, your human users. Of course, you can invert this whole system and make your game built for bots. I have pictures here from the TV show Robot Wars, in which basically it's bots fighting bots, which is a really viable and exciting sort of category. Of course, it does minimize your potential user base to those who can build bots. But we have to be careful while building these composable systems, because we're essentially making them extremely accessible to what are potentially our worst users. The final one is basically value as a primitive, and I think this is just across the board something that makes building in this space interesting. We've worked with money inside of software or value inside of software for a long time, but there's always sort of a disconnect from the value that's represented in the system and the value as it exists inside the meat space. There has to be sort of meat space institutions to enforce that relationship. And when value is an actual primitive in the programming language itself, you're able to have a higher fidelity and build things like flash loans, where there is sort of synchronous enforcement instead of this perceived, oh, well, will it be enforced afterwards by meat space? Can we rely on that? So that just has a phase change in what's possible as a programming language. Of course, it lends itself really well to casino games. This is, you could say, if porn was to the internet, I'd say casino games are to blockchain. Another double-edged sword, of course. I think we're all here familiar with the benefits and drawbacks of building on chain. But I would, as a side note, like to make a claim for gambling, not necessarily as the lowest form of human existence, but as a final and effective weapon against bots. Random number generators are the only truly equitable force inside of a game that treats bots and humans equally, and bots will never have an edge over humans in a sort of fully random scenario. I have a picture here of backgammon, which is a great example of not fully random, but somewhere in the middle, where backgammon is a game that the world's best player or this hyper-optimized bot can still lose to the world's worst player. The chances are low, but they're never zero. And after many, many games, of course, a better player will prevail over time. But because there is elements of chance inside these games, and I think you realize in so many games there's elements of chance, it creates a destabilizing effect that makes for really exciting gameplay and an opportunity for human players, bad players, to still prevail over hyper-optimized bots. And quickly, I wanted to touch on the term autonomous worlds. I think probably everybody here is familiar with it, but I think it's exciting not because of all of these other elements that are inside of it, some of them that I've mentioned already. I think the term wasn't around when I got into the space, but I think it's pretty clear those were the ideas that I was interested in, this idea that you could build a world that was bigger than yourself, something that was large enough, exciting enough that other people would want to occupy or build their own things inside of. But what I think the term autonomous worlds really is a flag and a commitment to stop making bad games. We've had on-chain games since the beginning. They've just mostly been bad, and for different reasons. I think we can go over some of them. Why have they been bad, actually? And some reasons are good, some reasons are bad. We still and have always had pretty bad UX, dealing with private keys, cryptography, dealing with gas, on-ramps and off-ramps, which is really bad user experience. I'd say that we also succumb to allowing and encouraging bad users. So these are the users who are essentially not playing a game for the intended purpose of the game, maybe to have intrinsic value, fun. But it is the sort of double-edged sword as well of incentivization. It's that playing a game is no longer intrinsically valuable. It very quickly becomes extrinsically valuable. You can make money from it. And this can really sort of disrupt the other that you would think you would like to still preserve in a game, which is that games are fun. And it means that you sort of push off this core loop of making a game fun further and further, especially if you are making a game to signal the fact that you've made a game, to signal the fact that your game company is valuable, to signal the fact that you should care about this game company, to signal the fact that you should use this game. This is a really toxic loop because people will move and act as if they're players, participants. You will have good traction, except for it's sort of this weird zombie dance because nobody's actually playing the game for what you would think they'd play a game for, which is to have fun. And I think there's a lot of viability in that path, but I think probably a lot of the people in this room are here because we feel like we could make them fun. We could make the games themselves good, and I think that's really what's underneath that banner of autonomous worlds. Of course, there's also very real problems with making fun games, even if you have the best of intentions, and most of those are around limitations on computation, expressivity, and limitations on speed. As a result, I think we've seen some of the best attempts sort of restricted into these grid-based movement type games. A blockchain is pretty good at emulating a board game. various sort of low action turn-based activities. And some of those games are really fun, and I think we've seen some of those arise. However, it's just really limiting, if you think about all the different types of games out there, to have all of them sort of pushed into the category of board games. And so this talk and the techniques and some of the things that I've seen outside of this talk as well that I'm most excited about are sort of pushing that phase change into even just one step more of expressivity, as sort of represented in Super Mario, which is, of course, an old game, quite limited on its computation, but still, you can see here with this min-max look ahead, has extremely complex possibility space. Because that GIF is so good, I'm going to keep it on this slide. The ways we're dealing with speed and complexity today are multifaceted. I'll mention two of them. One is kind of the MUD v2 lattice, I'd say Dojo as well. And the problem with Solidity, I think, generally is that, sure, it's kind of a naive language, but it doesn't scale well for complex applications. And so MUD is basically a framework for making large-scale applications. But the trade-off there, of course, is that computationally intense applications, especially in the EVM, have gas-prohibitive costs. I think their attitude is kind of gas be damned. The cost will eventually be so low that it doesn't matter. But at the end of the day, they're still limited by block time. And most blockchain games are, even if they've solved other types of computation expressivity. And this is the idea that the state update can only get down to at best a second, maybe slightly sub-second, but nowhere near the sort of milliseconds that we would expect in a general sort of player experience. So I think Validium games are really viable. This talk, again, is minimum viable Validium game, and I'll get into exactly what that architecture I think looks like best, and the one that I've been working with. But you have kind of two categories that you could go down. One is the zero-knowledge virtual machine. And the problem with virtual machines, even with sort of various optimizations, is that you're making proofs that the actual underlying code is being executed correctly. And so if you may have a method that's 5 lines of code, that, of course, gets converted to eventual bytecode, and then you're sort of proving that all of those operations were executed correctly. So 5 lines of code can get turned into hundreds, if not thousands of lines of proofs, of circuits or of constraints. And of course, the more constraints you have, the larger the proof, the longer it takes to make that proof, the more hardware you need to generate that, the more sort of single points of failure, et cetera, that can enter into your system. And so the opposite of this is doing the sort of like hand-coded circuits, which is extremely painful, but I suggest worth the sort of trade-off. And in that scenario, that 5-line function that we talked about a second ago in the zk-VM can be represented as still possibly 5 lines, maybe more, because you have to do such bizarre, dumb things when you're writing polynomial expressions as stand-ins for like functional logic. But you're able to reduce the number of constraints by such a large factor that you can still sort of preserve the sovereignty that you would expect from this kind of game experience. And what I mean by that is that there's certain limitations that at least we imposed on ourselves for building this system, and those include things like allowing the user to generate the proof in the browser in under a minute, and also not being sort of beholden to any one specific chain or architecture. I think that as we see the world move really quickly and the options around it, it's good to be able to be mobile and versatile and sovereign. I mentioned that I'm coming from the Cosmos ecosystem. I'm kind of a sovereignty maximalism. I think being able to be in control of your own system is one of the most important parts of delivering what you set out to deliver. And this ecosystem is rife with opportunities to compromise on that. It's much easier to just get grants from different foundations and never actually deliver a product that has to generate an income because it's doing something valuable. So this sort of configuration, I think, preserves that mobility, preserves that sovereignty. And I'll go into what that looks like. The general sort of concept, of course, is play first and verify after. So I still call it an on-chain game because the state transition of the game occurs on-chain. It's trustless. There's no third party that you're relying on. Everything is sort of independently executed. But you would basically play the game locally, create a proof of that, and submit it on-chain. The general sort of flow of making a zk-SNARK applies here. when you're making a proof, you have public inputs and private inputs. Generally, the public input would be your initial game state. So this could be a Merkle tree, which represents a massive, all-encompassing sort of world that you need to. And then, of course, you can include inside the private input the relevant state to verify that it's actually part of that universal Merkle root. Or if it's not that big or complex, you could just make all of the state itself part of the input. What's nice about public and private inputs, private, of course, has privacy. It means that nobody gets to see it at the end, so you're able to preserve which moves eventually make their way into the game. But there's another sort of benefit of that, which is when you're actually creating that proof at the end and you need to verify it, those private inputs don't need to be a part of the thing that is eventually submitted on chain. And that's a potential gas-saving technique. So even if it's not necessarily private, you're able to reduce the gas impact by removing it. But again, that private user input is generally thought of as, I like to think of it as kind of keystrokes for a keylogger. So the game starts out with the initial state, and then the proof takes all of the moves that a player would have used when playing that game. And I think the best way to kind of do that actually is by using real game platforms, allow users to have the interfaces and the move systems that they would expect to, but record them, because if we're using deterministic systems, these moves could be replayed and the same state can have the same output. A good example of this is an artwork by Radical Software Group from the 2000s. This is called How to Win Super Mario Brothers Tabulature. So they attached a keylogger, basically, to a Nintendo Entertainment System controller and recorded every single keystroke that occurred. You've got left, right, up, down, B, and A, and then it's recorded in kind of guitar tabulature mode. And then they published this as a hardcover book. So of course, this is kind of like a useless object, but you could imagine the actual content could be replayed through an emulator, and the result would be a successful win of the game Nintendo Super Mario Brothers. So if you were to create a zk-SNARK of this entire system of the game, you would be able to, as private inputs, provide this, and as an output, say every level was completed, or this is the final score, this is the final time, and a proof that says, yes, there's no way somebody could have done this without having actually played all of the moves correctly. Of course, again, that public output is the final game state, and potentially relevant aspects of that, speed or score, and the proof. Submit all of that on chain, and you have successfully updated state on chain for a game that is far more complex than would ever be possible on chain, and with the possibility of moves and interactions taking place at a much higher rate than would have ever been possible with a block state update. I mentioned Circom as this. Right now, it's my kind of favorite circuit language for this possibility because it's used in production by a number of projects, including Tornado Cache. It's, I think, kind of the right balance between like the math, because SNARKs often involve polynomial expressions, and you want to really have strict access to that phrasing so that people aren't sort of making decisions on your behalf with a compiler and maybe adding more constraints than are necessary. This is really kind of like Jedi Ninja stuff where it's a little bit like Solidity gas golfing too. You're really trying to reduce the complexity while still preserving the meaning of the code. Again, it's faster and cheaper than zk-VM. Blockchain devs, of course, love to suffer. They generate solidity verifiers, as I mentioned, sort of targeting an EVM as a final goal provides a lot of versatility and sovereignty. And again, I'm kind of a sovereignty maximalist, so that is a nice configuration to allow that mobility and versatility of targeting final states. But you might realize that these are really only good for single-player games. And of course, we all know that blockchains are massive PvP games that we really want to be making multiplayer games. We know that multiplayer games are the most exciting, the most fun. But at the same time, when you're on a blockchain, you're already alone together. I think many of you know that there is actually an easy way to turn a single-player game into a multiplayer game, and it's by letting many people play it at once. I have a statistic here from World of Warcraft, completely irrelevant in the picture, but as I understand, quoted while you would expect World of Warcraft to be mostly player versus player, actually 90% of it is player versus environment or one-player games. So people do actually skew towards one players, even if they find value in the kind of multiplayer features of the community around it or the competition at the one-player scale. Although, side note, maybe multiplayer too. I think some of the projects in this room especially have developed or are developing ways to recreate a lot of the architecture that I just described, but still allow for various aspects of multiplayer. I think the sort of next phase change of complexity from what I'm looking at ends up looking mostly like a state channel, where as I play it off-chain, put in all the moves, create the proof. If I were to introduce other people into that scenario, we would basically be sending our moves to each other, verifying them with each other. We don't even need any sort of zk-SNARK at that point. We just need basically validating from each other's signatures. It could be useful to have some kind of a zk-SNARK and a conflict resolution at the very end of it, or you could have all of the signatures themselves go into the SNARK itself, but I think it's maybe redundant. So to be soon, maybe TM, possibly. But in the meantime, I think speedruns are really where this single player mode shines. Speedruns have been around for a while. There's a really vibrant culture. It also has this kind of alone together aspect of it. They're absurd. I mean, you can see somebody years after release of Mario beating it and having a huge following, a huge time. Momentous records are set all the time. I'm sure some of you all have seen some speedruns. And what's really great is you can kind of speedrun anything. So I don't know if anyone saw when Cranked That by Soulja Boy became a sort of topic for speedruns, recreating the whole song inside of music software, and whoever could recreate it completely accurately, the fastest, was sort of setting that record. And the numbers started dropping really fast as different people sort of competed to get the first ever sub 17-second Cranked That. And what's also a nice sort of element of all of this is that there is this kind of problem inside of speedruns of validity. So I don't know if you've ever seen King of Kong, Fistful of Quarters. Great movie, probably one of the best sports arc movies of all time, but it's about competitive Donkey Kong players. And there is like the most amazing evil villain in that movie who maybe has cheated after his title is ripped from him from years and years of dominance. And there's this huge problem about people validating the speedruns, watching hours and hours of video footage and then a glitch in the video footage, maybe somebody like doctored that image, et cetera. Here's some pictures from somebody who had set a new record inside of Minecraft, but of course it turned out it was completely fake and everyone was freaking out because, how dare you put in a fake result? But if your game is modeled already inside of one of these environments, by creating a proof that you finished the game in that time, you're creating a proof that you played the actual game as well. You don't have to sort of like trust my screenshot at the end that has the score. You have a lot more credibility and actually the validation and verification of speedruns. So this is relevant outside the blockchain space as well. Quick overview of just how we've been applying this. So we're Trifle. I'm going to hold this because I realize I think I'm a little over time. We sort of began with early gaming in our mind. You could think of the first game as a descendant of asteroids. Early on, we started modeling the three-body problem as a way to sort of put physics on chain as a kind of initial problem to grapple with. The restrictions we put on ourselves was to make sure it was always under 1 million constraints. This would allow the prover to be under 1 gigabyte, which is necessary for a person's browser to be able to create proofs and to make sure that those proofs are under a minute. So here's an example of the first version that could run basically 20 seconds at 25 frames per second and still satisfy those conditions. Then one day we realized that actually it might be really fun to shoot at these things. And so adding a little bit more complexity, we were able to get 26 seconds, 25 frames per second. Fast forward a few months, we now have a game called Anybody Problem. There are 5 levels. Every single day there's a different game. Each level will require 1 to 6 proofs to prove the gameplay. And that's running with logic at 25 frames per second and the visuals at 50 frames per second. That means that every game has maximum 1,500 steps, or every level. And we're able to create proofs for all of these in between 10 seconds and 1 minute in the browser, depending on how fast you beat the game. If you beat the game faster, you have less proofs to generate. And we batch all of the proofs into a single transaction. So you can play the game all the way to the end, and then you can decide whether you want to save your score by submitting all of the proofs. We're still in stealth mode, but coming soon to an EVM near you. We expect to launch in August. If you're interested in following our progress, you can look us up at trifle.life, trifle.life on Twitter, or myself, Billy Rennekamp. And if you're interested in a playtest, please DM me. Thanks very much. Any questions before I wrap it up?
In the case of speed runs, do you even need to do the proof of that stage? Just enough that you've got a record of the deterministic run. So like in the Mario, so you've got the book, but you didn't need to prove that.
Yeah. One aspect that may still be relevant for like trad gaming is the privacy aspect of it. So I want to prove that I beat the game, but I don't want to necessarily give away my secret sauce. Although I think for ours, we've been thinking about a way to, as one of the public outputs, be a hash of the moves that you made, so that you can optionally later prove the moves. That makes it really fun if the 24 hours is done for the game, so there's no really threat of somebody stealing it anymore. But you want to be able to watch them, and with that moveset, you can deterministically recreate the entire gamer experience without like a video recording. You can high fidelity recreate it, which I think is a really exciting possibility that sort of was a happy accident. All right, thanks very much, everyone.